The calculation of sample size for a therapeutic trial is a critical step in clinical research. It ensures that the study has enough participants to detect a clinically significant effect while avoiding over-enrollment. Below is a detailed explanation of the methodology used to calculate sample size for a therapeutic trial. Key factors influencing sample size. 1. Study objective and hypothesis. Determine whether the trial is a superiority, non-inferiority, or equivalence study. Formulate the null and alternative hypotheses for the primary outcome. 2. Primary outcome. Define the primary endpoint, e.g., survival rate, mean reduction in symptoms, etc. Choose whether the outcome is continuous, categorical, or binary. 3. Effect size del. Specify the expected difference between treatment and control groups that is considered clinically significant. For example, a reduction in blood pressure of 5 mmHg or a 10% improvement in survival rates. 4. Variability in outcome, C. Estimate the variability in the primary outcome based on previous studies or pilot data. For continuous outcomes, this is the standard deviation. For binary outcomes, the variability is derived from proportions. 5. Type 1 error. Select the significance level, commonly set at 0.05. This is the probability of incorrectly rejecting the null hypothesis when it is true, false positive rate. 6. Power, 1 to Bell. Set the desired power of the study, commonly 80% or 90%. Power is the probability of correctly rejecting the null hypothesis when the alternative hypothesis is true. 7. Allocation ratio. Define the ratio of participants in the treatment group to the control group, e.g. 1:1, 2:1. Attached sample size calculation for different study designs. 1. For continuous outcomes, for comparing two means, e.g. reduction in blood pressure, n equals frac z1 and alpha vel 2 plus z1 sigma delta sigma right 2, where z1 alpha 2, z-score corresponding to the significance level, e.g. 1.96 for off 0.05. Z1 beta, z-score corresponding to the power, e.g. 0.84 for 80% power. Delta, clinically significant difference between groups. Sigma, standard deviation of the outcome. Stopped for binary outcomes. Arringto, for comparing proportions, success rates. N equals frac z 1 z beta 2 times p1's p1 p1 plus p2 1 p2, p1 minus p2 2, where p1 and p2 expected proportions in treatment and control groups respectively. For time to event outcomes. For survival analysis or hazard ratios, n equal frac z1 alpha 2 plus z1 hr 2 dot d, where's hr hazard ratio. D, number of events required, calculated based on event rates. NARS 4, adjustments for dropout. Account for potential loss to follow-up, n text adjusted equal frac n 1 minus text dropout rate. For example, if the dropout rate is 10%, multiply the calculated sample size by frac 1, 0.9. Steps in practice. 1. Define inputs. Collect all necessary inputs, effect size, variance, power, significance level, etc. Use historical data or pilot studies if needed. 2. Select formula or software. Choose the appropriate formula based on the type of outcome or use software like GPower, PASS, nQuery, online calculators. 3. Adjust for study design. Account for cluster randomized designs, stratification, or multi-arm trials if applicable. 4. Verify assumptions. Sensitivity analysis may be conducted to evaluate how changes in assumptions, e.g. variance or effect size, affect sample size. Example calculation. Scenario: a therapeutic trial comparing a new drug with a placebo. The primary outcome is blood pressure reduction. Delta 5 to mmHg, clinically significant reduction. Sigma equals 10 mmHg, alpha equals 0.05, power equals 80%, 1-to-1 allocation ratio. Calculation: n equals left frac 1.96 plus 0.845 right 2 equals left of frac 2.8 0.5 or equals 31.36. Thus, 32 participants per group are needed, rounded up. Conclusion: accurate sample size calculation is essential for the validity and feasibility of therapeutic trials. By using the appropriate methods and tools, researchers can ensure their study is adequately powered to detect meaningful effects while minimizing unnecessary costs and ethical concerns.